Welcome to CS225, Computer Science 2 for the fall 2021 semester. This introductory module gives you basic course information. It's basically first day of class, let's go over the syllabus kind of a lecture. So before we get started, let's be clear, this is not the Java class. It's an object-oriented class. We're teaching you the object-oriented paradigm. We happen to be using Java. There are no labs first week of class, so the first lab begins on Tuesday, September 7, I believe. Yes, we have live in-class lectures. The university is not doing online this semester, and so we have live in-class lectures. Attendance is not required, strongly encouraged. Basically, historically, people who don't come to class fail, so please don't fail. I recommend getting the textbook. It's not a bad textbook. We don't do homework from the text, but I do use text examples. I think they have a lot of good code examples in there. You'll need to download software to your computer, specifically the latest the Java Software Developers Kit. Actually, version 8 is good, and Eclipse. Lab 1 that's the job of Lab 1, is to help you do that. We'll get links provided in the discussions, and then we also give people help. You can take this course with a Mac. It seems to work just fine. Okay, so here are the outcomes for this module, and this is the setup for all the modules in the course, right? We have outcomes, and then we have a discussion about those outcomes. But this is the thing that you should look at to say at the end, did I get it? Right? Do I know what I need to know from this module? So basically, like I said, standard syllabus stuff. How are we going to run the course? What are the course policies? What are you expected to do? How much effort is required? How do we determine your grade? These kinds of things. The course has three major themes. First, it's the introduction to the object-oriented paradigm. So the people who have taken this course are required to have some familiarity with programming. Tends to be an imperative programming style, MATLAB or C++, used as if it was imperative. And so we'll transition to Java. There is an expectation that you have had a previous programming course. So while we're going to go over what it means to have a loop or what it means to have an if-then-else, the expectation is that you've seen that stuff before. Now, that doesn't mean that we're making an assumption that everybody's a great programmer. That is not the assumption. It's just you have a passing familiarity with the basics of programming in the procedural or imperative modes. The next thing is the introduction to professional software development processes. So the current big process running around in the world today is the Agile Scrum process. We'll use a modified version of that for this class to get you set up for understanding what you're going to be needing to do as a team in the SE 300 and in follow-on courses, and if you get a job as an intern or in industry somewhere. And then also introduction to software design, some introductory material on data structures, algorithms, things that are basic to software construction. The course is primarily the content, all the assignments, these lectures, notes, all delivered via Canvas. Obviously, we'll have in-class lectures, and my goal this semester is to use the material that was developed during the pandemic that's on Canvas and leverage that, not depend on the in-class lectures so much for that material, review it in class, but then actually do exercises, have you guys actually do work in class so that you're not just listening to me ramble, you're actually doing something, practicing. Okay, so what do we have to do in the course? It's a 4-credit course. It's not hard, but it does take effort. The topics are not conceptually difficult, but there is effort involved because you have to practice. So, complete 10 labs. That's a 2-hour lab every week, roughly, and that's pretty easy. I mean, the scores in the labs tend to be really high, so in terms of getting a grade, that's a place for easy money. complete 10 homework assignments. I expect that 8 of those will be coding, 2 will be software design. Do 1 peer review exercise. My expectation is we'll do 1 that is required, and then I'll probably have others out there for extra credit. And then do a project. The project is broken down into 7 separate deliverables. Then there's also extra credit opportunities available. There's an extra lab, there's an extra homework. We'll have speakers come in and talk at the university. If you go see those speakers, you get extra credit for that. So there's a fair amount of extra credit available. Okay, so isn't that a lot of work? Yeah, it's a lot of work. But no, it's not too much work in the sense that over the years we've put estimates on all of the activities based on student feedback, and most students are able to get all of the work done. Now, the trick here, it's designed to be 10 hours a week, though. I mean, that's a fair amount of work. That's a fair commitment. But that's the design. And the trick here is that, particularly in programming, people have widely variable abilities to get code completed in a particular period of time. So I've asked students for feedback on a particular homework assignments. How long did it take you to do this course? I'm sorry, to do this homework. And I'm hearing, oh, it took me 1 hour. Oh, and it took another person 15 hours. Okay, so is that too much work? Yes, but this is within your control, and I'm strongly encouraging you. Every assignment we give has a time estimate attached to it. If you are going over that time estimate, don't keep going. Stop. Just stop, and then ask for help. We have amazing TAs in this class. I'm available most of the time. Stop and ask for help. You will find that stopping and asking for help means instead of spending 2 hours and not getting anywhere, you spend 10 minutes with somebody and your problems are resolved. Okay, so the material's not difficult, but you do have to practice it. The only way to practice, the only way to learn to code is to code. You can listen to someone talk about it all day. The only way to learn to code is to code. And that means doing the work. But be smart about it. If you're taking too long, if you're spinning your wheels, stop and ask for help. This is right out of the syllabus, so I'm not going to go over this. These are the topics that we believe we're covering in the course and that you should be able to master or have a good familiarity with by the time that we get to the end of the semester. Okay, let's talk about grading here. The course is broken up into 2 components. One is quiz, homework, and lab. I'm keeping that nomenclature even though I don't plan on any quizzes this semester. Quiz, homework, and lab, that's 1 hunk of points. And then your projects are a separate hunk of points. You get graded separately on each. Your course grade is the lower of the 2. I tried this as an experiment last semester, and I'll have some comments on that later on in this talk. I'm going to keep trying it this semester. I don't think people's grades suffered, but it basically kept people honest. Prior to doing this, I was getting people who were getting a whole bunch of points in the labs, because that is really easy to get good points in the labs, and then not showing that they really understood the material at all by turning in a really substandard project and still getting, say, a B in the course. Well, I didn't feel that was indicative of their understanding. So I tried this last semester. We'll have comments about this later, and I'm doing it again this semester. This is really important for you to remember. Basically, it means you have to do both halves of the course. You have to do some kind of effort on the project, some kind of effort on the homework and lab. Now, for the most part, students get A's and B's in this course when they do the work. Usually the issues with grades below that is literally people are not turning in work. So we'll talk about that more later. Here's a brief description of the schedule. As you see, we have no lab for the first week, and then we start labs after that. I've broken the course up into modules, and modules 1, 2, 3, 4, and so on are the normal course material in a sequence, and then module 99 is the project. And so what we tend to is on Mondays and Wednesdays we do the progressing through the course material, and then every Friday we have project discussion. And so the idea is we are dedicating time for you to think through and plan through the project, and we fold in the course material as we go. At the end of the semester, if you look after Thanksgiving, there's no more lectures per se. Actually, module 11 is there's no testing required with that. It's just information that I'm giving to you. So there's no work associated with module 11. So if you go all the way back to 8th November, your workload, the plan is the workload goes way down. You effectively have no more labs. Lab 11 on week 14 is an extra credit lab. And so the last few weeks of the course are solely devoted to project time. So the idea is to give you time to complete this thing with an environment where you can get some help. I'm strongly encouraging you to work in the classroom. The labs the TAs will be available during lab time for tutoring, for help with projects. I'll be in the classroom for tutoring and help with projects. So the idea is come to class, do your work in class. Excuse me. And that way, at the end of the semester, you won't have all this project work plus additional work. Deliverables, anything with a P is project, HW is homework. Okay, labs. There's no labs for the first week of the class. All the lab information will be on the Canvas site inside CS225. So in Canvas, you have a CS225, a CS225L. We're not going to use the CS225L. Everything's in CS225. Labs are run by Robert Apelian. He's experienced. He gets great reviews. And Daniel Khalil, who also has experience and gets good reviews. And then we'll have a few other newer people. The TAs are one of the strengths of this class. Each lab focuses on a specific skill. And then at the end of the semester, we stop doing labs and reserve those for tutoring and project help. Homework assignments. The key here, late homework is not accepted. With this many students, we cannot have the grader running nuts, particularly at the end of the semester trying to catch up on grading. So late homework is not accepted. We have 10 required homework assignments and 1 extra credit. Submit everything via Canvas. Each homework, we have a time estimate attached to it. We try to size them, so that they're nice bite-sized chunks. And again, late homework not accepted. It just doesn't work for this course. For the project, the idea is you're supposed to do a, quote, relatively sophisticated project. Individually, it's not a team project. There are 4 things that we have to have in the project. You have to use inheritance, which we cover in the course. You have to have a graphical user interface using JavaFX. We have to have exception handling, at least 1 example, and file I/O, at least 1 example. And we'll go over this in nauseating detail as we go through the semester. You get to choose the topic, but I have to approve it, and there are some topics which are forbidden, which I will cover when we start talking about projects in more detail. 7 deliverables throughout the document. There's a design document, test and requirements document, a planning and tracking sheet, and then 4 software deliverables. There's also initially a proposal, a short proposal. The idea behind the project is you're taking the individual skills that you're learning in the course and putting them together into one larger piece, and at the same time learning or being exposed to at least good software design principles and good software production principles. Okay, what about student feedback? Let's see, here's some feedback from spring semester. What was most helpful in the course? The TAs, right? These guys are great. I totally agree with this. Use these people. They are really interested in helping. They love talking about coding. And so you are not imposing on them by asking them questions. The labs and the TAs are helpful. Now, why are the labs helpful? Again, it's great to come to lecture and listen to me talk, and we're going to try to do some exercises in lecture. But again, the only way to learn to code is to code. And that's really where you get to do that is in the labs, at least in a structured environment. So you can learn the principles in the lectures, then you get to apply those principles by actually doing something in the lab. That's how we've designed the course. And we've timed it as best we can that you get material in the class, practice it in the lab, and then show you can do it in the homework, and then have that skill available to you for your project. That's the intended design of the course. Use these people when you need help. Me also. It's just there's more of them, so they're more available to you. Okay, student feedback. What's least helpful in the course? Back-to-back homework and labs. A lot of times it became overwhelming. Okay, so what I've done this semester, this is new for this semester, rather than having any post-lab work, I'm going to ask the lab instructors to replace that with homework. So and before there was lab, post-lab, and then homework assignments separately. Sometimes they did pile up on each other in terms of schedule, especially with the weird shortened schedule we had last fall. So what we're doing now is not doing post-lab and instead having a homework that relates directly to the lab. So the post-lab and the homework kind of gets combined into one thing, and I'm hoping that takes some of the effort down for the class. What's least helpful? And I'm not going to read that whole comment. You can pause the video and read that. You know, I don't understand why Garfield talks about how hard this class is and how it takes 20 hours a week. Okay, I never said that. What I said was this class does require effort, but if you're spending 20 hours a week on it, you're doing it wrong. Okay, so it takes longer than the credit hours. It means you're a bad professor. So again, my response to that is, if you find that you're taking a long time on a particular assignment or a particular piece of code, stop. Don't keep beating your head against the wall. Stop and ask for help. Help is available to you. Quite frankly, this is one of the hardest things to get students to do, is to stop and ask for help. But I encourage you to do that. Right? I encourage you to start to learn to show your ugly work to other people, because that's what the real world looks like. That's what industry looks like. I rarely understood the homework assignments because you do not teach the actual coding part of it. Not true. I disagree with that. The skills that you use in the coding assignments are directly related to the material that we just had. So again, this semester I'm trying to leverage recorded lectures so that we can reinforce those things in the lecture, but then have more time for people to do active work, to actually practice coding and practice software design in class. The grading. There are a couple of comments about grading. Wish the grade scale wasn't the worst grade in your class. The grading, are you kidding me? On and on. I'll let you pause the video and read that. And then another, grading is stupid. And so again, this is an experiment that I tried in fall 2021. I think it was worth continuing in the spring. Even though I got a couple of complaints about this, overall the course did well. So if you look at the breakdown from spring, there were 42 A's, 15 B's, 13 C's, 3 D's, 12 F's. Of those 12 F's, a good half of those were, and maybe more, were people who were just not active in the class. They literally were not turning things in. They literally were not coming to class or asking help or trying to clarify what they were supposed to be doing, particularly in the projects. So they got bad project grades. So again, the thing I'm trying to fix is, since the labs are so much effort, they need to have points associated with them that recognizes that effort. But it's also easy money. It's an easy way to get a bunch of points. And previously, students were basically coasting on those points, and then I don't believe their final grade actually reflected their understanding of the material based on the work that they were doing with their project work and their homework. Least helpful thing, some of the things Garfield teaches us are not applicable in the real world, which includes this heavy documentation before coding. And then this person says, in the reality, you code like crazy to get the product out the door and then do the documentation afterwards. What this person is describing is one of two things: either a startup company, which is a small startup companies don't rely as much on documentation, or a completely dysfunctional process, a completely dysfunctional situation. My experience in industry, which is dated, is that documentation is very important, and other faculty have more recent experience in industry where documentation is very important. Our industrial advisory board has all made sure that we know that we need to teach students how to do documentation and how to understand how process works. So the documentation we do in this course is actually quite light compared to industry standards. We use Agile Scrum. One of the principles of Agile Scrum was its goal was to reduce the amount of documentation. It's true, industry 10, 15 years ago tended to have really big, heavy documentation trails that weren't that helpful to the actual product. That's changing. The kind of documentation we do is in line with current industry standards. In this class, we do it quite lightly. We do, this person said heavy documentation. I would argue that this person has not seen actual documentation before in an industry environment. So we're looking for maybe 10-page documents as opposed to hundreds of pages of documentation in industry. So I think that the documentation, number one, if you use it correctly, what it's going to do is force you to think through what you're trying to do with your code before you start coding. And there's value in that because it makes the coding easier. Ideally, the coding is trivial. It makes you understand what you're trying to code, how you're trying to code it, and then testing to verify that you actually coded it correctly when you're completed. In addition, we need to prepare our students for any work environment. You might get out of here and go to a small 5-person startup, and you may not be that interested in documentation. Or you may work with Boeing or Lockheed or any of the larger, more established corporations, and I promise you, you will be inundated with documentation there. So we need to prepare you for any kind of these environments. Again, less focus on documentation, more on actual coding. My argument there is that if you don't know what you're trying to code, then you will spin your wheels while coding, and I've seen it dozens of times. Typically, I have students who tell me they have a coding problem, and then we start to talk about it, and what they really have is a design problem. They don't know what they want to do. And if they don't know what they want to do, of course they're having trouble coding that, because they're not sure what they're trying to end up with. So the idea here is use the documents as they're intended. It forces you to think through what you need to do prior to actually sitting down and typing code. There's some conflicting feedback here, right? The UML diagrams in particular are especially annoying, and then another person said, hey, these UML diagrams were great, you should really bring them up sooner in the course. So, and I think I have a way to do that. So I'm not sure what to do with those competing comments. It's pretty normal in student feedback to get competing comments, by the way. So again, one of the themes of this course is about software development and software development processes, and the documentation is part and parcel of that. Use that to your advantage. Make it where you know what you want to code before you start to code. Don't do the standard thing that, quite frankly, we all do. Oh, I'll figure it out as I go along. No, you probably won't. So figure it out ahead of time, then do the coding, and then you will find that the hours that you spent creating the documentation gives you payback in many hours that you didn't spend coding. Okay, so that's a rundown of the course. That's a rundown of some of the student feedback we got before and my responses to it to let you know what I think the course is about and why I've made certain decisions in the course. And I will see you on Monday, and we will go from there.